Hello friends, in this video we will talk about energy management using information technology. As we know, conservation of energy remains a strong rationale for urban centers to use smart technologies. It is estimated that cities consume about 75% of the total energy requirements of the world. There are many reasons behind this. This consumption is for industrial production, in factories, in offices, and also for running services such as transportation and for domestic consumption. A key goal of smart cities is to monitor and control energy consumption. Energy management requires locating and measuring the generation, storage, distribution, and consumption of energy. Each of these stages of the energy life cycle requires sensing and monitoring for efficient management. Energy generation is usually carried out by the traditional means of central power generation plants that use hydropower or are based on fossil fuels. In many cities, because of uncertainty in power supply from these centralized sources, many industrial and other organizations install their own captive power generators or specialized generator plants that essentially rely on fossil fuels. Solar power also has gained prominence in recent years, and many cities have begun to invest in massive solar panel installations, sometimes over rooftops and buildings also. Photovoltaic panels convert solar power directly into electricity, whereas thermal collectors convert solar energy into heat energy, such as solar water heaters, which are installed usually on roofs. These sources of electricity generation may be located on individual buildings and homes in cities, thus creating a large mass of micro generators that may be connected. Cities in some regions that have windy environments rely on wind energy obtained from massive wind turbines located on hilltops. In all these cases, the challenge is to sense and monitor the extent of energy production at all these sources, and also to decide on how these can be stored and distributed. Electrical energy is typically stored in batteries of various forms. These batteries may be monitored to see when and how they do charge and when they have to be recharged. Energy is also stored in superconducting magnetic energy coils as a potential energy in water pumped to higher positions. Typical variations in energy need include sudden peak in demand owing to weather changes or gradual demand growth owing to industrialization. Cities try to balance the different needs with different storage and monitoring facilities. The key objective of these efforts is to retain sustainability. Energy distribution in smart cities follows the smart grid concept, where each energy generator and storage location is connected to a grid, and this grid is also connected to consumption locations. The function of the smart grid is to distribute energy from supply sources to demand points based on price expectations or contractual obligations and sustainability criteria. The key idea of a smart grids is to meet customer demand with existing energy without resorting to building new facilities with an architecture that is resilient and can withstand natural forces and calamities. So the smart grid is usually an interconnection of many macrogrids that operate independently of it and are called to pull together only in times of need. Such an arrangement requires a strong communication backbone that is robust and constantly online. So there is a lot of possibility of such type of IT-enabled energy management in our country, especially the urban locations, the urban cities in India is a potential place for such implementations. Friends, in next video we will talk about a different case study. For this video,